Hello, algebra students. These lectures, I'm sorry that I'm not there in person. It'd probably be easier if I was in person. But the advantage here is that when I give you problems to do, to practice on right now, just pause the video and then do it. Take as much time as you need and then restart it, and then that way you can see how it's solved. For that reason, these videos are not going to be the whole 50 minutes. They're going to be significantly shorter because we spend a lot of time in class, going slowly and working through problems. But I'm going to leave a lot of that to you to press pause. So seriously, don't just watch this thing straight through unless you get it. And even then, you really should pause it after every problem that I give, do the problem, and then restart the video. So I'm going to cover the same amount of material in this lecture as I would in a class. It'll be shorter. So let's begin. This is Monday's material, and so this is the next page on the website, and it's just more on lines. And I know that some of this is hard to read from your video, but I'll make it bigger. Basically, this says find the equation for each of the following. And then write the answer as y equals mx plus b and draw the line. So this is just a review of stuff we've already done. So why don't we do, actually these are I think the exact same problems, aren't they? Holy cow. Okay, so let's try number 5. It says m is 0 and it goes through the point 4, 5. For this one right here. So what that means is, let's find the point 4, 5, 1, 2, 3, 4, and then up 5, 1, 2, 3, 4, 5. So it's about right here is the point. But the slope is 0, which means the rise over run is 0, which means no matter how much you run, it never rises or falls. So that just makes this a horizontal line like that. That's it. And so the equation of this thing is just it's basically y equals 5 because it stays like that. But if you wanted to do this formally, you can say y is equal to mx plus b, where m is the slope, and that's 0. So what we can do is we can put in the point here. So 5 is y, x is 4, and m is 0. So this gives us 5 equals 0 times 4 plus b, but this is 0, so that means b is equal to 5. So the equation is y is equal to 0x plus 5, but that's just 0. So y equals 5 is the equation. As another example, in number 3, the 2 points, if you can't see them, are 3, 1 and 4, 6. So the first thing we want to do is find m, and m is always the difference in the y's over the difference in the x's. So 6 minus 1 over 4 minus 3, and that gives us 5 over 1. So then, to find the equation, we can use either one of these points. So I'll just choose this one right here. So y equals mx plus b. So y is 1, m is 5, x is 3 plus b. So I'm going to subtract 15 from both sides. That's what this is, 15. And that gives me minus 14 is equal to b, which means the final answer is y equals mx plus b. So y equals m x plus b, and b is minus 14. So let's see. The next one, it says draw these lines and find where the lines intersect. Okay, so this is these are good problems. So so the first one, let's draw them. So again, this is these two are y is equal to 2x plus 5, and the other one is y is equal to 3x minus 1. So these are already in mx plus b format. So the y-intercept is 5, 1, 2, 3, 4, 5. And then the slope is 2. That means it rises 2 for every one that it runs. So it's going to look like this. So that's this equation. This equation, the y-intercept is minus 1. So that comes down here. And the slope is 3, which means that it rises 3 for every one that it runs over. So, and then right here, so it's going to look like this. And so notice that these two lines will intersect at a point. And the way we can find the point that they intersect at is, notice that wherever they intersect is they have the same y value. So what that means is I'm going to set these two equations equal to each other and find out what x that gives me. So if I set those equal to each other, we have 2x plus 5 is equal to 3x minus 1. And now let's solve this. So I'm going to add 1 to both sides. That gets rid of that. And then I'm going to subtract 2x from both sides, and that gives me x. Now I just did 2 steps in one, so if you're unsure about that, then just solve that equation by yourself and make sure that you get x equals 6. So now that I know, in other words, they intersect at the point x equals 6. So 1, 2, 3, 4, 5, 6. So I know that they intersect about right here, actually exactly right there, and I've drawn. So if you go up and find the corresponding y value, I'll see that I've drawn this pretty well. Now I want to find the y value corresponding to that x value. So which of these equations do I put the x equals 6 into? The answer is it doesn't make any difference because we're finding out where these two equations give me the same value. So let's put it into, we'll choose this one. So if x equals 6 there, you get y is equal to 3 times 6 minus 1, and that gives me 17. But if we tried it in this one also, I hope we get the same answer. If we try this equation, we get y is equal to 2 times 6 plus 5, 12 plus 5, and that indeed gives me 17. So the answer to this, it says draw the lines and find where they intersect. The answer as to where they intersect is the x value is 6 and the y value is 17. So go ahead and do number 3 right now, which is well, it should be in your, you should print out these papers, but it's 4y plus x equals 1 and x equals 6. Now pause the video and figure out where they intersect. Okay, so the answer to this one is actually quite easy because we're already told that x equals 6. X equals 6 is a vertical line, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 right there. It's a vertical line that looks like that. So, and then this, what I'm going to do is I'm going to solve this for y. So what that means is I'm going to take this, I'm going to subtract off x, so we get 4y equals minus x plus 1, and then I'm going to divide by 4, so that gives me y is equal to minus x over 4 plus 1 over 4. So what that looks like, here's the y-intercept is 1/4, which means it's real close to 0. And then the slope is minus 1 over 4, because there's a little imaginary 1 right there. Well, it's not imaginary, it's a 1. So the slope is minus 1 over 4, which means that it drops down 1 for every 4 that it moves over. So it's going to look something like that. So the intersection is going to happen right there. Now, what is that point? Well, the good news is we already know what the x value is, because x is constant. It's always 6 for this line. This is x equals 6. So what I'm going to do is I'm just going to put in the value of 6 into this equation, and that gives me y is equal to minus 6 over 4 plus a quarter, which gives me minus 5 over 4 as my y value, which is about a little over minus 1. So I've drawn this actually okay. So the answer here, the point of intersection, is 6 is the x value and minus 5/4 is the y value. So move over 6 minus 5/4 is about right there. Okay? So the rest of this, now I see it says actually the same as the last section. So these should be review from the last section. But this is new. So your homework then for this lecture would be to finish these if you haven't already, and then also to find the answers to these, which is where the lines intersect, and also to draw them. What I'm also going to introduce in this section, in this lecture, because this last part was, we didn't add a heck of a lot to it. So now I'm going to add the concept of parallel and perpendicular lines. So again, this comes right from the website. This is says worksheet 2.3, part 3. And now the question is, for each of these lines given below, state what the slope of the parallel line would be and what the slope of the perpendicular line would be. Well, let me explain what these mean, first of all. So if I have a line y is equal to 3x minus 4, we know what that looks like. You go down 4 spots, and then it has a slope of 3, so it's going to look like that. The word parallel means same slope. So any parallel line to this is any line that has the exact same slope. May not have the same y-intercept, but it has the same slope. So this is parallel, and so forth. These all have the same slope of m equals 3. Perpendicular means that the slope is at right angles to this. So a perpendicular line to all of these would be this line, and so forth, because it forms right angles with the other lines. So it has a slope at right angles. But how do you find that? So a parallel line has the exact same slope. So the slope of every line that's parallel is going to have a slope of 3. But perpendicular, there's this cool rule which says that the slope of the perpendicular line is the negative reciprocal. So 3, if we want to find the negative reciprocal of that, 3, of course, is the same thing as 3 over 1. So the negative reciprocal would be negative 1/3. So if I want to find, in fact, what was the problem? The problem was state what the slope of the parallel line would be and the slope of the perpendicular line. Okay, so in these problems, all it's asking you to do is to find, well, what are the two slopes? So for example, in number 2, where it says y is equal to 13x minus 4, the slope of the parallel line, and by the way you write the symbol for parallel are two little lines that are parallel relative to each other. And the way you write perpendicular is two lines that are perpendicular to each other. So these are symbols. That means parallel and that means perpendicular. So the slope of the parallel line is the same as this, 13. The slope of the perpendicular line would be negative 1/13. Pretty easy. So go ahead and do let's do number 5. Pause the video and do it. Okay, so for number 5, what I'm going to do is we need to put this in the form y equals mx plus b. So I'm going to add y to both sides, and I'm going to subtract 8. So that gives me 3x minus 8 equals y. So now we've got mx plus b. So once again, the parallel slope is 3, and then the perpendicular slope is minus 1/3. This one, 3 and 4, are these concepts of horizontal and vertical lines. So for example, y equals 4 is a line that is horizontal, which means that its slope is 0. But its perpendicular slope, which means any line that is perpendicular to that, unfortunately, does not have a slope. It's perfectly vertical. Its slope is, we call it undefined. But conceptually what that means, what is the rise over run? In other words, how much, if you're starting, say, right here, how much do you have to run or rise on this line before you can move over? Well, the answer is you never move over, which means you keep rising forever. So another way some people call this, the slope is infinite. That's not perfectly accurate, but it's good enough for now. Or you can call it undefined. Okay, so now it asks you, in the next set of questions, it says, find the equation of the line that is parallel to the given line and passes through the given point. So, for example, so what we wanted, and then of course the next set of problems is going to be, we'll find the equation of the line that is perpendicular to the given line and passes through the given point. So let's do one of the parallel ones first. Let's do number 2. So number 2 says 2x minus 3y equals 4, passing through point minus 1 and 5. So to do that, the first thing we do is we have to write this in terms of, we have to write it in the standard equation for lines. So I am going to subtract off 2x from both sides. So that gives me minus 3y is equal to minus 2x plus 4. And now I'm going to divide by negative 3 to get y by itself. We get y is equal to 2/3 x. Oops, not plus. It would be plus minus 4/3, or minus 4/3. So, now that we have that, we know that the slope of all parallel lines is 2/3. So now all we have to do is we have to find the equation of a line having a slope of 2/3 that passes through this point. So the way I do it is, I know that I'm looking for an equation that says y equals mx plus b. Let me do this on a bigger piece of paper so you can see it. So I'm looking for y equals mx plus b. And I know that the slope is 2/3, and I know it passes through this point, negative 1, 5. That's x, that's y. So I'm just going to put in the values. Here is my y, here is my x, and then here's my slope. So what this becomes is 5 is equal to, the slope is 2/3 times x, which is minus 1, plus b. So that gives me 5 is equal to minus 2/3 plus b. Now I add 2/3 to both sides and I get b is equal to 5 and 2/3. Which means the final equation should be y is equal to mx plus b. M is 2/3, x, and then plus 5 and 2/3, which is b. I'm going to go ahead and move on to the perpendicular one because it's the exact same concept. The only difference is for the slope, we're going to take the negative reciprocal. So let's try number, in fact, why don't you try number, oh, that's exactly the same. It is the same. Look, these are the same equations right here. So why don't you try number 2 down here. The only difference is we've already solved it in terms of its form. The only difference is now the slope of the perpendicular line is going to be the negative reciprocal of that. And it's passing through the same point, negative 1, 5. So take a few minutes and figure that out for yourself. Pause the video. Okay, so in this case, because we've already done this before, we solved for y. We got y equals 2/3 x minus 4/3. Then to find the slope of the perpendicular line, it's the negative reciprocal of that, which is negative 3/2. So our slope of the perpendicular line is negative 3/2. So now let's just do it. Let's just put it in that point. So we have 5 is equal to the slope of the perpendicular one is negative 3/2 times x is minus 1 plus b. So that gives me 5 is equal to 3/2 plus b. I subtract off 3/2 from both sides and I'm going to get 3.5 is equal to b, which means that the equation then is y is equal to mx plus b. Here's m minus 3/2, x, and then here's b plus 3.5 or 7/2. This is 7/2. Now there's another way to do this, and you might remember this if you when you took algebra in high school. It's called the point-slope form. And what it says is, once you have the slope, and once you have a point, you can just put them into this little formula, which says y minus y1 is equal to the slope times x minus x1, where x1 and y1 are your point. So, for example, in the most recent one we did with the perpendicular going through that point, remember we found that the slope of that perpendicular line was negative 3/2, and the point is negative 1, 5. So using the point slope formula, what we get is y minus 5 is equal to minus 3/2 x minus negative 1, which becomes x plus 1. But if you factor this through, what this gives you is y minus 5 is equal to minus 3/2 x minus 3/2. I distributed the minus 3/2 through there. And then I add 5 to both sides to get y by itself. And that gives me y is equal to minus 3/2 x minus 3/2 plus 5. And these are 7/2, which is the exact same thing that we got before. So I don't know that point slope form actually saves you any time, but some people love it. So I don't really care as long as you give the answer in the way that I ask, which will usually be the standard form, which is y is equal to mx plus b. So I want to reward those who are diligent in watching these videos, and if you've gotten this far, email me, which is and just include your name, in case I don't recognize it from your email address, and give me two things. Give me one, something you understand in algebra, and then something you don't. Something you don't. I have terrible handwriting. Something you don't understand in algebra. They don't have to be long. The first person to send me this will get 5 bonus points on the next test, which is half a grade. And then everyone else who sends this to me before class gets an additional 2 points. So that's all you have to do. And then you'll get that extra credit. So what we're going to do next time is we are going to move on to circles. So circles are, we'll discuss this beginning in the next video, but essentially a circle is a curve that is not a function. And the reason it's not a function is because it fails the vertical line test. So if you for example, at this point x right here, what is the outcome? What is the result of inputting x right there? Is it this value or is it this value? And because we don't know, it is not a function. But nevertheless, we're still going to learn about how to write the equations of circles. And that's it.